Hello, Mr. Walber here, talking to you about plate tectonics today. We've been talking in class about continental drift, seafloor spreading. Obviously, eventually over time, enough studying of the interior of the Earth, we have come to the conclusion that there are plates there. The plates are made of what's called the lithosphere, and it is the crust. The crust can either be continental or oceanic, and that, with a little bit of the mantle, sits on top of the asthenosphere, and that's what slides and moves, causing us to have plate tectonics. If you want a full look at the interior of the Earth, and we will study this more in the chapter on earthquakes, you can see, obviously, the lithosphere is the top part, the asthenosphere is down there. We have the upper mantle, obviously the rest of the mantle, the outer core and the inner core. We, as I said, will study that much more when we get into earthquakes, but just kind of have an idea of the different parts of the interior of the Earth. There they are. Different boundaries that we have. Number one, and please pay attention here, is a divergent boundary. A divergent, if you think about two roads diverge, they go apart. I give you the example of the Atlantic Ocean. We've been talking about the Mid-Atlantic Ridge. The separation of plates there would be a divergent boundary. The Red Sea, Iceland. The Red Sea's here by Africa, and as the arrows indicate here, this is just getting farther and farther apart, and you come back in a few million years, this is going to be just all water in between that. Right there you can already see some lakes and stuff popping up, but that will just get bigger and bigger over the course of time. Earthquakes are prevalent here, and volcanoes are as well. I told you that rocks and minerals are not going to go away, and here's a prime example. I want you to think of a rock that is basaltic and a rock that is granitic. We talked about this with igneous rocks. An igneous rock that is basaltic is going to be very dark, and especially important here to understand is it's dense because it's high in iron and magnesium. Granitic rock is not as dense as basaltic. Why is that important? Because when we have a convergent boundaries are when plates come together. There are three kinds of convergent boundaries. You might want to look on 483 in your book to reference this. When oceanic crust meets continental crust. Now, oceanic crust primarily is going to be basaltic rock. Continental crust is granitic. When these things collide, the oceanic plate is denser. It's going to subduct underneath the continental, as it shows you here. As that plate goes down underneath, we are going to start having a few things happen. First of all, the rock down here is going to melt, and we're going to get magma. Obviously, that's going to start to rise because it's liquid and it's less dense, and that's how volcanoes form. But also, as this grinds down underneath, we get a lot of earthquakes, and this will buckle up, and we get very violent volcanoes because all this pressure is built down in there. And a good example of that is Mount St. Helens and the Cascade Mountains. The Andes Mountains in South America are another good example of that. When two oceanic plates collide, they both basically go down, and you get very, very deep trenches. Eventually, one is going to subduct underneath the other one, because obviously one's got to be more dense than the other, but they're both going to create a very deep trench here. And this is going to go down, and we're going to get, again, the melting of rock into magma, and that magma is going to want to rise, and it's going to start to erupt, and you get little islands that form, and they call these things island arcs. They're basically just nothing but volcanoes that eventually pop up above the sea level, and you get little islands. The Japanese islands are great examples. There's a number of different ones out in the Pacific like that. A lot of the islands that World War II were fought on. Hawaiian Islands, I will tell you, I'll warn you, they are not oceanic to oceanic plate boundaries. That is something we'll study when we get to volcanoes. The last convergent plate boundary example is continental to continental. Continental crust, remember, is again made out of granitic rock, so you're not going to get any subduction. Big, very, very big mountains are going to form, but no volcanoes. You're not going to get any subduction, so no magma is forming. Lots of earthquakes. A good example of this is Mount Everest in the Nepal, China area, where India crashed into Asia. Highest peaks and the highest, biggest mountain chain in the world is the Himalayan mountains, and that's from a continent-to-continent plate boundary. The third and last plate boundary is what's called a transform boundary, and that is where you get two plates that slide past each other. The San Andreas Fault is probably the most famous. That is in California. More recently in Haiti. Haiti is a really bad, had some really bad earthquakes recently, and they are another transform boundary. But as the arrows indicate here, you got one going this way, one going this way, and you get a lot of grinding and rubbing against each other, and that's going to cause lots of earthquakes. Again, no volcanoes. You're not creating any magma. Nothing is going down and melting. It's just a grinding past each other. So that is a transform boundary. If you look at the map here, I showed this to you the other day in class. This is just a great place to look at where things are happening. Very prevalent places for a lot of volcanoes, a lot of earthquakes. Obviously, we've already mentioned the Mid-Atlantic Ridge right here down the middle of the Atlantic Ocean. California is a transform. The San Andreas Fault, it's right here. As I mentioned, the Andes Mountains right here. The Nazca Plate subducts underneath the South American. You got some volcanic mountains, right along here. I said India crashing into China. Right here's India. This is Asia right here, and China, this is the Himalayan mountains, so that'd be a continent-to-continent plate boundary. So there's examples all over the place. I'd take a minute and look at this. Here's the key, obviously, and hope you learned something. We will see you tomorrow.